NASA discovers a strange object in the universe. The first interstellar comet is Comet 2I Borisov. On August 30th, 2019, amateur astronomer Gennady Borisov from Crimea made the discovery, which soon spread to other parts of the world. Following a week of worldwide observation by amateur and expert astronomers, researchers were able to trace the path of the flittering visitor and confirm its extrasolar origin. Hey everyone, welcome to Discovery Scene. In today's video, we will explain exactly what we found, a strange object that was discovered by NASA. So do you want to know more about Borisov? Make sure to subscribe to our channel to unveil all of those shocking discoveries. Comets are ice, dust, and frozen gas snowballs. They are roughly the size of a small town when completely frozen, but when heated by the sun, their tails can extend for millions of miles. Approximately 0.61 miles, 0.98 kilometers, is how long 2I Borisov is. The journal Nature Astronomer has published the most recent findings regarding the makeup of the comet. It is leaving our sun quickly and will eventually travel back into interstellar space where it will remain forever. In October and December of 2019, the comet 2I Borisov was photographed by NASA's Hubble Space Telescope as it sped through our solar system at a breakneck speed of about 110,000 miles. A bright nucleus was visible in the images, but the nucleus itself was too small for the Hubble to see. Hubble images taken in March 2020 revealed a distinct change in the comet's appearance. Rather than the comet's previously observed single bright inner core, the images suggest a fragment had broken away from the nucleus. Hubble will still be used by scientists to keep an eye on the comet. Only one other extrasolar visitor, officially known as Oumuamua, has been discovered. In 2017, it sped out of the solar system after passing the sun at a distance of 24 million miles. It's still unclear to scientists whether Oumuamua was an asteroid, comet, or possibly a combination of the two. However, when heated by the sun, the interstellar comet's tail can be extended for millions of miles, according to NASA. After emerging from somewhere in deep space, it is a most pure object to come to the solar system. Oumuamua traveled 38,100,000 kilometers, 23,700,000 miles, from our star to the sun. It didn't, however, act in a comet-like manner. Normally, as a comet warms up and approaches the sun, frozen volatiles are released through sublimation, creating a hazy coma. It was established that Oumuamua was an interstellar object, not a comet, due to this and the way it teetered awkwardly through space. So far, the first confirmed interstellar comet is now 2I Borisov. It also acted like a comet. It did sublimate some of its volatiles as it got near to the sun, creating a hazy coma. It released some of the same substances that nearby comets can, including diatomic carbon, carbon monoxide, and water. A high carbon monoxide to water ratio suggests that the comet originated from a very cold region, one that is on par with the Kuiper belt, which is the region where Pluto is in relation to our sun. A red dwarf, the most prevalent type of star in the Milky Way, may have served as the starting point for 2I Borisov, according to the Hubble using teams theory. The planet-forming material surrounding red dwarfs would be colder than the elements that make up our solar system, because they are smaller and less bright than our sun. No matter what kind of star 2I Borisov originated, scientists using ALMA speculate that it may have been a piece of a dwarf planet with a lot of carbon monoxide near its surface. The ALMA team suggests that 2I Borisov might have simply just formed as a comet with a high carbon monoxide content. Alternatively, it might have an unusually thick layer on the outside that protects frozen gases like water and hydrogen cyanide. The more volatile carbon monoxide may appear to be more prevalent than the other cometary gases, as it evaporates or outgasses. The peculiar characteristics of 2I Borisov may also point to a greater variety of carbon monoxide in comets in our own solar system than was previously believed. The Oort cloud, which is much further away, and the Kuiper belt, which includes Pluto, are the two regions in our solar system where the majority of comets are found. All of these comets probably originated closer to the sun, but they might have been pushed further away from it by the erratic motions of Jupiter and Saturn billions of years ago. Because of these massive planets' powerful gravitational pull, comets may have been launched away from the sun and toward other stars. Given this background, researchers using Hubble hypothesized that 2I Borisov may have been thrown our way by a massive planet in a red dwarf star system that existed in a climate with frozen carbon monoxide. Comet 2I Borisov's trajectory is being slightly altered by the sun's gravity, but due to the comet's path and high velocity of about 177,000 kilometers an hour, it cannot be captured and pulled into orbit. The comet's heart is a loose clump of ice and dust, according to observations by NASA's Hubble Space Telescope. Hubble enabled astronomers to detect signs that a comet fragment had broken off in March 2020. Hubble-based follow-up observations are anticipated. Are you curious to know more about Borisov? Then keep watching, and don't forget to hit the like button and subscribe to our channel. ALMA pointed at a region of the sky where 2I Borisov was anticipated. A precise orbit trajectory, accurate to 1/5000th of a degree, served as the foundation for this. In order to create an amorphous image of the comet and learn more about its composition, the telescope collected a spectrum of energy released by the comet's gases. The researchers started by looking for hydrogen cyanide, the most readily observable cometary gas. The discovery was not entirely unexpected, given that other researchers had used optical telescopes to discover the closely related cyanide gas in 2I Borisov. However, the situation was different with carbon monoxide. The emissions of CO are much weaker and more difficult to detect than those of hydrogen cyanide. Nearly no effort was made by the researchers to find the gas in their dataset. But the team's low expectations were dashed when the data from Chile arrived. Compared to other gases, the signal for CO was typical. Unlike our Sun and its family of planets, Comet 2I Borisov formed in a different star system. It might be considerably more ancient or more recent than our 4.5 billion-year-old family of worlds. A large number of comets that first form around our Sun have been ejected from our solar system, primarily as a result of gravitational collisions with Jupiter. It is therefore possible that Comet 2I Borisov was expelled from its planet in a similar manner to this. All the comet ices are volatile, but carbon monoxide is the one that evaporates the fastest when it gets warm. Accordingly, based on how much CO it had preserved, the comet most likely formed very far away from its star in one of the coldest environments known. 2I Borisov would have been born close to the Kuiper belt if it had formed around our Sun. Models predict that temperatures during the solar system's formation may have reached negative 420 degrees Fahrenheit, in this donut-shaped region of icy bodies beyond Neptune's orbit. Scientists believe that 2I Borisov may have left its home star system due to gravitational disturbances caused by young jiggling planets. Although Comet 2I Borisov's surface has not been directly observed, comets from our own solar system have rough surfaces that are occasionally covered in smooth sheets of icy, dusty debris. Comet 2I Borisov is too small to support its own atmosphere because it lacks sufficient mass and gravitational pull. However, Comet 2I Borisov developed a coma, which is a dust-filled cloud of gas surrounding the comet's nucleus. A coma is created when ice is warmed by solar heating and lofts fine dust off the comet's surface and into space. It is possible that 2I Borisov simply formed as a comet with a lot of carbon monoxide. The more volatile carbon monoxide escapes and appears to be more prevalent in comparison to the other gases that make up comets. Alternatively, it may have a thick thermally insulating outer layer that keeps gases like hydrogen cyanide and water frozen. The Comet 2I Borisov is not the first to baffle scientists with its eerily high carbon monoxide concentration. A comet named C2016R2, Pan-STARRS, which was discovered in 2016, was even more remarkable because its CO levels were thought to be many times higher than Borisov's. With current technology, it is challenging for a spacecraft to reach Comet 2I Borisov due to its hyperbolic excess velocity of 32 kilometers a second. A 202-kilogram spacecraft could have been launched in July 2018 to intercept 2I Borisov using a Falcon Heavy-class launch vehicle or a Space Launch System, CLS, class booster, but only if the object had been discovered much earlier than it needed to be to meet the ideal launch date, claims a team from the Initiative for Interstellar Studies. Later launches would not be able to use Falcon Heavy-class rockets, necessitating O-berth maneuvers close to Jupiter and the Sun, as well as a larger launch vehicle. Presently, it appears that Comet Borisov has fragmented. A number of brightening events on Borisov were reported in mid-March 2020 by the astronomers. They claimed there were 2 transient brightening episodes and 1 subsequent permanent one. These observations suggest that the nucleus of Borisov has fragmented. Then, on March 28th, Hubble images revealed that, in contrast to images that had been taken just a few days earlier, Borisov's nucleus was longer. Then on March 30th, Hubble revealed that Borisov was indeed breaking into 2 pieces, judging by the appearance. Here are some amazing videos that I believe you will enjoy. Simply click on the video to watch it. Stay tuned for the next one. Goodbye.